the circles, aren't we?
How do I spell?
All right.
How do I spell that?
So let's get going here. So yes, it is. We know a square, right? We've got 4 congruent sides, and we've got 4 right angles. Okay. From a square, what else do we have? We got ourselves. This is also a rectangle. Okay, in a rectangle, okay, with a rectangle, we've got right angles, okay, and a rectangle, we've also got 2 pairs of congruent sides. It just so happens, though, in this particular one, we've got all 4 sides are the same, right? So it's just a special case. What else, anybody, can we say? We get ourselves a parallelogram as well, okay? So in this, we get ourselves a parallelogram hiding here as well. Okay, anything else that we can say we have? Carter?
It's a quadrilateral.
For sure, it's a quadrilateral, right? Yeah, I mean, at the very top of this family tree, it's a 4-sided figure. So at the top of every family tree of 4-sided figure, it is a quadrilateral. I know it sounds kind of silly to say, but no, it definitely is. All right, what else do we have? A shape. That is definitely true. I'm looking for at least 1 or 2 more.
Figure.
I heard somebody say it. It's not a figure.
Number 1.
Rhombus. Okay, so a rhombus. We've talked about rhombus before. A rhombus is another 4-sided figure. All the sides are what? Congruent, the same. And the rhombus, the rectangle merged together, and that makes us the square. The rhombus has the 4 congruent sides. The rectangle has the 4 right angles. That makes it the square. So a rhombus and a rectangle. And then there's one last one. And the last one here is kind of the odd man with this, how it's defined. Anybody? Throw out maybe one more quadrilateral name that you know of.
Trapezoid. Yeah, for sure.
Yeah, it's the trapezoid. What's that?
You said triangle.
Please don't. Okay. It's the trapezoid. Now, the trapezoid's the odd one here. And the reason why it's being thrown in here with the square, the way that it's being defined, trapezoid being defined here into this part of this square, it's at least 1 pair of parallel sides. The word's saying at least. And how many sides does a square have that are parallel? 2 pairs of parallel sides, right? So when we say the word at least 1 pair, it has at least 1 pair, right? It's got 2. So square encompasses just about everything, doesn't it? Imagine kind of inverting this family tree then. We start at the top of quadrilateral. Quadrilateral goes then to a trapezoid. So trapezoid has at least 1 pair. After trapezoid, we go to a parallelogram. Parallelogram has actually how many sides parallel? 2 sides parallel. And then from a parallelogram, we go to one of 2 options. It depends on if we have right angles. Rectangle, we've got right angles. Rhombus, we don't. And then together, rectangle, rhombus make a square. Okay, so with that in mind, what can we say about the second one then? Looking at number 2 there. We got ourselves a quadrilateral. Okay, so let's kind of invert that family tree that we did. We got ourselves for sure a quadrilateral. That's a 4-sided figure. We got a quadrilateral. Now, thinking kind of again what we just did, we kind of got an inverted family tree here. And at the top of that family tree, yes, it's quadrilateral, but after that is going to be a trapezoid, starts it off. Again, the reason why we're starting with the trapezoid is the way it's defined is it's going to be at least one pair of parallel sides. Trapezoid has one, at least one pair of parallel sides, and after trapezoid gets us to a what? Correct. And that's what we've got going here. Parallelogram. I can't spell. Parallelogram. Wow. Okay. Now, those are parallel sides, are they? Those are not marked as parallel. Those are marked as equal lengths. Those are marked as congruent sides. But that implies one and the same, actually. That if you have congruent sides like that, that's also going to imply we have what we call it, parallel sides. So that's going to give us a parallelogram. Does that get us anything else after parallelogram? That does not give us a rhombus.
Yeah, I see that now.
Yeah, that's not going to give us a rhombus. These are congruent to one another, those are congruent to one another, but all four of those are not congruent. That's all we can say. Okay, we got nothing else about the angles. Those are definitely not right angles up there. So we are stopping at a parallelogram. How about the last one? We know it's a, okay, I hear a rhombus, which is correct. Now to get to that rhombus, how do we get there? Quadrilateral. And after quadrilateral is a trapezoid. And after trapezoid, we run into first a parallelogram. And after a parallelogram is a, goes one of two directions. It either goes to a rectangle or a rhombus. In this case, we're going towards a rhombus. Correct. And the rhombus gets us, in this case, 4 equal sides. The rectangle, we've gone the other direction. That's going to give us the what? Right angles, all that. But that's not what we have. We have a rhombus here. Okay. So we're going to bring in our quadrilateral family tree here today and talk a little bit more about some work with the properties of quadrilaterals, which we barely skimmed the surface of back at the beginning of the semester, which we're going to do a little bit more work this week on. So let's go ahead and flip it, and let's talk a little bit work today of some work with the diagonals. Okay, so diagonals. We know some. We've done some work with diagonals, not a ton. So talking about the diagonals of a quadrilateral. Okay. Now we have our. Hopefully you guys remember your concave and convex polygons. Now remember how you hopefully remember the difference between the convex and the concave. My teacher, it might have been 3rd grade, 4th grade, I don't remember. Concave, you walk into a cave. So that's how I always remembered it. You walk into a cave, and it's always stuck for me. So that's how I remember it is a concave. You walk into a cave. So if you've got that vertex that's kind of inside of the polygon, that's a concave. You walk into a cave. All right, so let's draw in our diagonals for each of these 2 polygons. For the convex, draw me in the diagonals. Where's the diagonals at? Vertex to vertex, right? Opposite vertex. So we're going to need them today, so I'm going to pass them out to you so you can get some nice diagonals, I guess, in there. We pass out the protractors. We're going to use the protractors not for measuring angles today, but we're going to use them for just your straight edges. Okay? So go ahead, use those protractors, the straight edges, for making those diagonals. Okay? So make that diagonal I was about to make there. Okay? And go make me the other diagonal. So where did I get the mark? Alright. Diagonal to diagonal, or vertex to vertex to make that first diagonal. Okay? And then go make me the other diagonal. What's the other diagonal going to be at? Okay. And boom. Let's go name these out. Okay. Because we're going to refer them down here below. Okay. Let's name these vertices A and C. B, and D. And where they meet up at, those diagonals intersect at, let's call that point. Let's get crazy and call it point E. Makes sense. So draw those diagonals in. Cool. Go draw me the diagonals in the concave one. Now, where's the first probably obvious diagonal at? Yep, I see Soraya pointing this one out right here. Okay. And let's go ahead and draw the second diagonal. Where's the second diagonal at? What's that? Above it. It's a weird one. It's not an obvious one. It's going to connect the other two vertices. And to connect the other two vertices, outside of it, isn't it? The diagonal's there. It's just outside the polygon. And that's going to be the case for a concave. It's a little odd in this case. Okay? So here, we're not going to worry about labeling these because we're going to focus on the convex. Typically, we focus on convex polygons. All right, but here in this instance, what we notice here is, or hopefully we're going to notice here, which answers this question then, well, what do we notice about the diagonals of a convex quadrilateral versus a concave? What do we notice about our diagonals intersecting? Inside versus outside, right? That in the convex, they intersect inside versus outside on the concave. Okay, so because of that concave, where that vertex has been kind of pushed in a little bit, that's going to happen. All right, it's a kind of again an odd one, but we don't really talk too much about the concave. We'll focus more on the convex one. Okay. So with that convex that we have, hopefully we have that again labeled out. Let's go do some talk about a lot of that vocabulary we've already looked at. So I think the next question asks me to start off by give me a pair of, I think it says, vertical angles. Okay. So somebody, go give me a name of a pair of vertical angles up there. So on question 3 right there. Give me a pair of vertical angles. Somebody name me a pair of verticals. Brianna? You gotta give me 3 points. Okay. Remember vertical angles? Yep, vertical angles. So trace it out. What's a pair of vertical angles up there? I'm sorry? AED. Cool. That's one angle. So angle AED is vertical with BEC, I heard. Yep. And what do we know about vertical angles? They are always congruent. So let's jot that little piece down to it. No matter what we've got, they are always congruent. AED is congruent to BEC. Okay. The other one that we have there is, let's remind you about a linear pair. So let's go back up to that picture. And what can we say about an example of a linear pair? Somebody? Looking back up at that picture, somebody give an example of a linear pair. It's a linear pair up there. Okay, what would you say there? BEC. Okay, we'll go with BEC. What does BEC go with to make a linear pair? AE what? AEB. Cool. So BEC, we're right there, and we're going to go with AEB. Remember, linear pairs are adjacent, and they're making a straight angle. So, you got to make a straight angle. It does, and they got to be adjacent, and that's what that does right there. Okay? Just trying to remind you guys about those from what we did beforehand, before Thanksgiving break. All right, because we're going to use some of those verticals, linear pairs over the next 3 weeks before everything wraps up. Okay? All right, let's continue on. All right, we're going to go a little bit of deep dive in here to the different types of quadrilaterals that we got. Properties of the different quadrilaterals. So if you got patty paper stuck in that book of yours, grab it out. If you don't have patty paper, hold on. I still got plenty of it. So it looks like if you do, great. If you don't, I got you. All right. You don't have any patty paper?
Oh, look.
All right. So we're going to use patty paper here to do a new type of construction that we've done already. You're welcome. So we're going to use this circle here to do a couple things today. Look at some properties of one of the quadrilaterals. First, discover what quadrilateral we got. Some of the properties that go with it, and also do construction there. So let's do this. All right, take your patty paper. And on that patty paper, let's put it on top of that circle. Okay. And what I want you to do is, well, let's do that exactly what it says. Trace segment QR on your patty paper. Okay, so I want everybody to trace segment QR on your patty paper. QR onto your patty paper, that's it. Okay, and I will, I can't quite do that very easily on my board there. Now, on your patty paper, all you got is, again, a segment QR on there. Now, what we're going to do here with that is create, stop freaking out. Okay. All we want to do here is create two things. We're going to create a perpendicular segment to QR. All right. Using nothing but our patty paper. And we also want to do here is create it such that it's going through that center of the circle. The center of the circle is at O, right? So that brings in our vocab words. What's the center of that segment? What's one of our vocab words where we talked about that splits that segment into two? Bisect. Yep, bisect. So how can we use this patty paper to bisect that segment that's on your patty paper? Was that fold in half? Exactly it. So let's take that patty paper. Take point Q, fold it so it lands on point R, right? Take point Q, fold it such that Q is on top of R, right? That's exactly what we're going to do. And what you've just now done is you bisected segment QR, right? QR is now cut in half. That's what we've done is bisected it. Now, what you've also done here is, with Q on top of R, you've also now created a perpendicular, perpendicular segment. So, with our patty paper in half, what I want you to do is go back now to your book. Q on top of Q back here, and what you should have here is your patty paper, the crease. Right here is what? Landing right at O, right? Yeah. Take your pencil, trace it along the crease, and what should appear on your notebook paper? A segment that is two things. It's right through O, and it's also perpendicular to, come on, Q. There it goes. And it's also perpendicular to this segment QR, right? Now I'm going to freehand mine. How do I mark that it's perpendicular? Put my right angle there now. Okay. So our patty paper is a nice little tool. We can do quite a bit with that. And we just did a perpendicular bisector on it. We cut that in half, and we also made a segment that is perpendicular to it by just folding it in half, Q on top of R. All right. Now what it also wants us to do then is connect those endpoints to draw in, and we're going to label those V and W. So we're on the same page. Let me make sure. Let's label that top one V and that bottom one W. V and W. Take your straight edge, guys, and now connect all those points. Q to V, V to R, Q to W, and R to W. Now we've just made some type of quadrilateral. Question is, what type of quadrilateral? Okay. I heard square.
It's a square.
It's a square. Or maybe a rectangle. Okay. Well, let's think about this. Let's go through and use some of our properties to kind of identify a few more things here on that. Just like you did a few minutes ago on our warm-up, you all said pretty quickly that very first one was a square, right? What gave it away as a square? What two things made it quickly a square? All the angles are right angles. Let's go identify that. Okay, I don't have any angles up there, do I? But what can I do? What can I do? All right, right here. Don't mark this in your book. Let's not make your book any messier than it needs to be. Right here, what do I have here? I get what type of segment? What did I just highlight? I highlighted diameter. Now this angle right here, let's go back to some of our angle work that we did before Thanksgiving break. That particular angle is what type of angle? Central angle or an inscribed angle? It's inscribed. Okay. So this is part of 180 degrees. Going backwards to an inscribed angle. Is it, you said it's inscribed, is it the same or is it half? It's half. So if this is 180, what's half of 180? 90. So we just have one angle there. We just found that that inscribed angle is half of its semicircle. Half of 180 is 90 degrees. Now we can play that game all over on the other side. This angle W down here, doesn't it do the exact same thing? This is an inscribed angle. Isn't that part of a semicircle up here? Half of 180 is 90. So far, so good. Now this gets messy quick, but go look at those other two angles I haven't highlighted yet. This angle right here, this angle R, if I go with my other color, didn't we just have a diameter here? And isn't that part of another inscribed angle? Half of 180 is? Okay, so hopefully you realize that what we have then is another inscribed angle, and therefore we have how many angles? How many right angles? 4 right angles. Does that make it a square yet? No, it could also be a rectangle. What makes the difference between a square and a rectangle? All sides are the same. Okay, as we can go through and take a look at here. All right, as we see here on these side links of how they're situated inside of this circle, right? Do we agree that these side links would all be the same length in this circle off these triangles that we've created? So with these triangles that we've created, okay, let's go back one more time here. All right, let's bring in that triangle congruence we led off with on our homework. You told me this is a right angle, didn't you? All right, it's messy. Okay, this is the diameter. What do we know about diameters? Diameters are all the same length, right? What else also happens here? When this diameter comes in and this diameter comes in, what happens to one another? They cut each other in half, don't they? You took your patty paper and Zariah said fold it in half, right? Fold it on top of each other. So we cut it in half. So what that does for us is This gives me a triangle right here. Side, angle, side. Side, angle, side. I get a crap ton of side angle sides, don't I? Side, angle, side. Side, angle, side. These four triangles are all congruent by side, angle, side. And since they're all congruent by side, angle, side, that forces the last side to be now congruent. The corresponding parts are congruent then. All four triangles up there are congruent by side, angle, side. Therefore, that side I just marked is congruent because of side, angle, side is working. Okay. What can we finally say?
A square.
It's finally a square. Yes, it sure as hell looked like a square, but we can't go by looks. So we can finally say it's a square, okay? And because we said it's a square, what else falls in place with the square? It's all the ones that we said on the previous page, wasn't it? It's a square, and followed behind a square, it's a rectangle. What else do we say? Rhombus, parallelogram. I can't freaking spell parallelogram. And that weird one, which is a trapezoid. And for sure, it is definitely a quadrilateral. Okay. Now, on that one, we're going to come back around real quick in just a second and talk a little bit about properties, the diagonals, and I'll wrap up today. Okay. But we just found the measure of the interior angles. Those four angles were all 90 degrees. Okay. We found it by using our inscribed angles, didn't we? And we just did this. You have drawn four triangles. Use these triangles to analyze length of each side of the quadrilateral. What type of triangles we had? Congruent by side angle side. We marked up that side angle side, and that side angle side gave us four of those, all congruent to one another. That gave us that sides of the quadrilateral. And then we wrap it up with what do we know about the diagonals? QR and VW, these are the diagonals. So if you look at that, what do we know about the diagonals of this square? A heck of a lot. The diagonals, I was rattling off, they did a lot here. Let's wrap it up then. They do three things. They bisect each other. Because they meet in the middle right there at point O in that circle, they bisect each other. What else do we know about them? They are congruent. QR is congruent to VW. Why? Well, it's the same diameter, isn't it? It's all the same circle. QR and VW is the same type of diameter. Bisect each other, they're congruent. And there's one other thing that's drawn for you. I can't think of it. That's the wrong page. What's my missing here? Hold on. Perpendicular, yeah. And that very first thing we start off with, they are perpendicular. They are perpendicular to one another. Three things happen. Those are three things that happen. Okay. All right, that's what we're going to work on. Keep working on that.